Okay, back with some more rules. The first two, we had our constant rule, which basically says the antiderivative of a constant is that constant, or times x plus c. And then we have x to the nth. We add 1 to the exponent. We divide by that new exponent plus c, and this works as long as n is not equal to -1. So let's talk about that more here in this video. If we had x to the -1 power, and we tried to do this rule on it, okay, well, the rule would say that we would do x to the 0 because -1 plus 1 would be 0. And then we divide by that number, and obviously we cannot divide by 0, so this is out. So how do we handle this x to the -1? Well, let's think about that a little bit more. Let's rewrite this. What is x to the -1 power? All right, yeah, it is 1 over x to the +1 power, 1 over x. And so now we're saying 1 over x. What is that the derivative of? All right, so think about that for a second. We did this already. We know what function has a derivative of 1 over x. All right, what is that function? Exactly, it's the natural log of x. All right, so the antiderivative of 1 over x dx is going to be the natural log of x plus c. All right, there we go, separate those two. We need our plus c there. And there's one other thing we need to talk about with this antiderivative. If we look at 1 over x, that function has a domain, right? And in fact, the domain of this function is all real numbers, except that x cannot be 0, because obviously when we try and divide 1 by 0, that will not exist, all right? What's the domain of the natural log of x? This is why I have you memorize your common functions. Natural log of x, if we can think about that function for a second, here's the graph of the natural log of x. Okay, it's basically, there's a very simplified version of that. Notice the domain of this function. All positive numbers are good, but there is no function over on the negative side. So the domain of this function is all positive numbers. The domain of this function is everything but 0. They don't match. We always need our antiderivative domains to match our function because we don't want to have a derivative that exists when the function, in fact, does not exist. That's not good. We need the function to exist over here, all right? So how do we do that? We just need to draw two little lines. 1, 2. As soon as we do that, now we have the function of the natural log of the absolute value of x. What's the graph of that? That's the graph of the natural log of the absolute value of x. What's the domain of this function? Well, we got negative values of x, we got positive values of x, and the only spot where the graph doesn't exist is at x equals 0, which matches that domain right there. So, moral of the story, the antiderivative of 1 over x dx is natural log of the natural log of x, absolute value of x plus c. Okay? And while we're talking about logarithms, let's go to the cousins of logarithms and let's talk about exponential functions. Let's do one more rule in this video. The antiderivative of e to the x dx. What's that equal to? All right, what's the antiderivative of e to the x dx? You know this, you can figure this out, because all we need to do is figure out what function has the derivative of e to the x. And we know e, we like e because e's derivative is itself, which means e's antiderivative is itself. Of course, we do need that arbitrary constant as well. So there's two more rules for you. We'll get the rest of the rules in the final video.